So the next step is RHODS. So we call Red Hat OpenShift Data Science Platform. So this is mainly used for AI, ML, and data science workload. And how can we access the RHODS web dashboard, right? So we didn't specify anything on the resource type while asking for the resource allocation from the code front, because RHODS is also an add-on within the OpenShift cluster. So we don't need to specify a separate resource type for RHODS. So that will be part of our OpenShift allocation attributes within OpenShift allocations. So all these allocation attributes going to be also shared among the OpenShift as well as the RHODS. And also there is no separate URL. We need to go to access the RHODS. So that is also part of OpenShift. So to access the RHODS, we need to log into OpenShift, and there is a drop-down menu option where we can access the Red Hat OpenShift Data Science. So here, it has a different interfaces where we enable all the project that are part of our OpenShift allocations. So once you get approved here, now we can see different options to start working with our resources. So first thing we need to create is workbench. So workbench, we can specify the name, description, and then we can select the notebook image that will be used for our Jupyter Lab. So here we can specify different type of images. Some of them are basic Python-based image, or if we have GPU-based images, then we can use TensorFlows, or even we are asking user to contribute on this one. So if you have any specific custom build images that you want to use on RHODS, then user can also contribute them onto our main stream. For example, here the RStudio based Jupyter Lab is also there. So because all the other extension can be added on the Jupyter Lab, and then we can create an image out of it. So for this example, I'm going to use just a simple TensorFlow. And TensorFlow, we have different versions available right now, but we can see what kind of packages are pre-built within this image. So you can see within this TensorFlow image, we have different packages already inbuilt. And we can specify what kind of resource we're going to use on this container. So either we can use small or large or medium, those kind of resource container size we can use based on our workload. And also we can specify whether we can use, we want to use GPU or not. So here I'm going to use 1 GPU for this notebook. And using the notebook, using the environment variables, we can inject some of the dynamic information that is required to be used on the Jupyter Lab. So for example, if we want to use some private key pairs or some user credentials, then we can use them here as an environment variable. But in my case, I will not use any. And also we provide this persistent storage kind of setup. So that will persist all the data and the output of this Jupyter notebook in this storage. So for this purpose, I'm going to use just 2 GB for now, or we can even use the existing storage here. So if you already have some applications or the output on previous work, then you can just attach that into this workbench. But in this case, I'm going to create a new one. And we can also connect with our external data connection source here. So suppose we want to connect some S3 compatible object storage, then we can just specify their access keys, secrets, endpoints, those kind of informations. And once that is there, we can just launch. So here, as we already mentioned, these are the packages, and this is the resource limit and request we can in this container. And also it is attached to this 2 GB of persistent storage that is available here. So the benefit is, even though we delete this workbench, this storage contains all your output data, so it can be attached to a new workbench later on. And also I configured this S3 data connection. So this one is connecting to object storage that we uploaded during our first demo. So that is connecting to this container, OCP container or cold store model. And this has this machine learning model in ONNX format. So that's how we connect from OpenShift to any external S3 compatible object storage. So this is the bucket name, and this is the URL that we need to provide, and some of the access key and security keys to connect with this object store. So that's a one-time configuration we can set up, and that can be reused for other workbench as well. So once that is set up, now we can launch the model server. So model server, we can just give a name, select the runtime. So runtime is because we are using this to predict the object in an image. So we are not going to use a GPU at the backend. So we are just using the CPU for this example. And then we can also specify whether we want to use any highly available replicas or not. If we want, we can specify the numbers. In this example, we'll just use one replica. And also we can check how much resource we need for this model server. So I'm not going to use more intensive workload, so I can choose just a small size. So once that is deployed, and you can see that a server is ready, but still we need to deploy the model. So once the server is ready, now we can deploy our model, and the model is located in our object storage. So that is stored in this file, in this folder. So we need to specify where that model is located. So this is the external connector to the S3 object, and this is my folder where the ONNX file, the machine learning model file, is located. And because this is ONNX file, I need to choose the model framework based on ONNX. So once that is ready, I can just deploy it. So the outcome is it's going to generate the inference endpoints in different formats. So formatting like simple RESTful APIs or gRPC-based APIs will be generated. So for example, you can see here, once that is done, it has the gRPC-based URL that we can use to connect with this server's inference model. And that is connected to the object storage here to do the analysis, right? So in our example, we're going to use the gRPC rather than using the RESTful APIs. So once that is there, now we can launch our notebook. So the notebook going to be based on the information that we provide on the workbench. So image, all the resource limit we set up there. So it takes some time, but so you can see that image has all these pre-built extensions or launcher. You can use terminals to go into the container, or you can use other tools here. And beside that, it also has integrated GitHub connectors, so I can just clone the repo that I want to include in this workbench. So for that, I have this simple example here where we are trying to launch that machine learning tool on top. So once that is there, now we can see the whole Git repo is cloned, and then we can run some of the notebook, starter notebook that is available in this repo. So because I'm using simple Python, so you can see the output within the cell. So it's doing some matplotlib. On the second example, we have some simple math graphical widget that is running on the Jupyter notebook. And also we have already included a GPU device in this environment. So you can see there is already one GPU being available. And you can use that GPU to run your other code on the following cells. So this is easy enough to get a GPU-based backend, and you can just upload your code on this notebook and then run from there. So we're going to see some of the real use case. How can we use that? So here we are just testing whether the Python kernel is available using Python 3.9. So it says everything is working. If we run it, yeah. So Python can be easily run here, and then we will try to train the model. So training, we are using TensorFlow, using some publicly available data set, and then execute this all cells in this Jupyter notebook. So the outcome will be one model file and Keras format, so that will be stored within this repo. And once that is uploaded, then there are a few other notebook files that I'm going to upload. Here we have the connection string that try to check whether I have this ONNX file on the appropriate S3 bucket or not. So to do that, I provide this connection string in a encrypted format. So it's encrypted format, and then we can decrypt that on our third one. So this is the decryption. We can use this key, and then executing this, we can see whether I have that ONNX file required to run my model or not. So what it tried to do is it tried to decrypt that connection and then connect to my S3 compatible object storage and try to see whether I have this model file in my object storage or not. So that is specified here. And then once it finds out, it generates the result here. So the model training is also working in the background. So it generates all the things that is required for my machine learning later. So here the Keras file is generated at the end. So yeah, so we tried to find out, and it says you can find that file with this size. Right? So it means we have all the model file on the appropriate folder that is specified into our model server here while deploying it. So the next thing, we can now test out our model server. So to do that, we need to have access to the gRPC endpoint, and then just update our fourth inference notebook file where we want to connect. And here we are trying to identify or predict the objects in this image. So the image looks like this. So we are trying to find out what are these objects running our model. So here we specify the gRPC endpoint that will be serving our model, our inference, and then we execute this. So we try to install all the packages. Here we are not using any GPU-based PyTorch. We are just using a CPU. But if you want to optimize, yeah, you can use more GPU-based code, and then it will be more efficient and fine-tuned. So here the object will be this one, and then it will generate those using our model. And also we saw the RHODS is part of OpenShift within your own namespace. So whatever you build or deploy on this one will also be seen in our OpenShift dashboard here. So the model server, the TensorFlow-based workbenches are also here. But even though you're going to really use it on your RHODS platform. So here it takes some time, but it tried to predict what are those objects, and it predicts with some confidence level here, like 64% or 88%. So this is how we can easily deploy our machine learning, and also using the deployed servers and the inference, we can test it out within our notebook files within the RHODS. But the real use case will be, how can we now deploy this as an applications? So for that, we just need to have some applications. So we call it as an intelligent app. So here we have some sample for that. And on the OpenShift, all we need to do is copy those YAML files. So here we have the front end based on front end that's going to serve it. And then there is another YAML file that's going to connect to the inference on that given gRPC endpoint here. So we can deploy those two YAML files, and then it will generate all the required resources and pods and containers within this namespace. So once that is ready, now you can see everything is running, and you can browse it through this. So the front-end interface is just, it's going to browse the video camera, or you can use the QR code to upload your image. And once that is uploaded, it will generate the result like this. So it's the same thing like we saw on the Jupyter Notebook file, but instead of using the notebook, it's going to use the web interface. Yeah, so this shows end-to-end machine learning workflow that can be done on RHODS setup. Is there any other questions?
So just to go back on the using RHODS, so the steps would be to create an allocation like in ColdFront for OpenShift first, right?
Right.
And then you're connecting to that in RHODS.
Mm-hmm.
And that sets up your own like namespace and stuff like that. And then RHODS is just an overlay of functionality on top of OpenShift. Yeah. Am I characterizing all that right?
Yeah. That's
okay. Yeah, there's kind of that little bit of a nuance there. I'm not sure if picked up first time around. Okay. So that gets us to the end of the demo. I think today you've learned a huge amount. That's also why we recorded this, and these will be available on our website as well. I encourage you to, the people who participated, to invite others to come. We have another session next week and the following week. Any of your grad student, postdoc, faculty friends, reach out to them, let them know that this exists as a resource that you can use here at Harvard. And we also operate it in combination with Boston University and Red Hat Research and developers for the Mass Open Cloud. And we're more than happy to, have sessions with your individual faculty and stuff like that. So, but we had a good overview today, and you can see that there's a lot of rich amount of things that you can do. Hopefully through the examples, you can see what other research groups are doing, whether they're using VMs or containers, and I think the RHODS platform is really nice to be able to do things in kind of the AI space and spin things up quickly. It leaves you less to have to navigate managing, and it really connects to doing those things for you. So really excited about the RHODS platform being available. And it's kind of akin to if you were on AWS and opened up SageMaker or something like that. So anyhow, so thank you all for participating today. And thank you, a huge thanks to Milson for a pretty amazing amount of content to spread in a matter of little over an hour. And so great job on the demos and stuff.